minutes, you're doing it next door.
I'm not against that either.
You're on your 15 minutes, better hurry up.
I am. Actually, I'm not. Here, watch.
No, I'm...
Now I am. That's fine. Time me. I don't care. Okay, guys. So what we're going to talk a little bit tonight about is time. How many people think they know time well? Anybody? Hey, we got one guy. Oh, I think I saw another hand.
8:19.
Not the time right now, just time in general.
That
Yeah.
was
You were asking, so I know better than to say yes.
Well, that's probably pretty smart.
That was my answer.
So here's what you need to know about time. It's relevant to all of us, whether you're a sysadmin with logs, whether you're a developer trying to put information into those logs, whether you're some kind of analyst in information security where time has a factor. All matters in IT rely on time. Even the help desk, because you're going to have somebody that's going to give you a call and say, my phone has the wrong time, or my computer has the wrong time. The computer probably has the wrong time because they were playing Candy Crush and wanted extra lives, so they turned the clock back. But one way or another, you will get that call. You think I'm joking?
No, I know you're right.
So, the reason why I ask who thinks they know about time is because I'll be the first to admit I don't know about time. Time is so complex, so convoluted, so insane, and yet it's deceptively simple, right? We got a clock, we got hands, we move around.
Vibrations of cesium atoms?
Yeah, absolutely. That's another way to measure time. See? But that clock is going to be different than probably your watch, which is probably going to be different than someone else's watch, particularly if they're in another time zone. Oh, did I mention time zones? Because, I mean, we all want it to be noon when the sun is directly overhead, right? So let's just fix that in time zones. But, I mean, that causes a problem too, because it's not always going to line up exactly, and nightfall and daybreak are going to be shifted weird. So let's do some daylight savings time. That's a great idea too, right? And suddenly this simple little thing, 12 numbers on a clock, has turned into pure insanity. And actually, I have a video of somebody that can explain it far better than me. And so we're going to watch a little video, and then we'll talk a little bit about time. I'll ask you guys some questions so that we can keep this short so we don't go on too long. And of course, you guys are all welcome to ask me questions. Hey, beer time's important too, because this is another one of these fireside chats. Although this one's a little bit stranger than most, which is why it's kamikaze. Stop it. Stop listening.
You can get that clock over here.
Okay, let's see if this will behave today. Warning, it won't. Come on.
Oh yes, good video.
Anybody recognize this guy? Oh, it blinked off again. Come on.
It's shy.
It is shy. There we go.
Yep.
Anybody recognize this gentleman? This is Tom Scott. If you have tons of hours to burn on YouTube and nothing better to do, go look him up because he's pretty awesome. And I love this video in particular because he really does, embody the madness that is time as he tries to explain it to you. It's 10 minutes, and so you guys only have a couple more minutes of me. Doesn't that sound good? We'll skip ahead if you get bored, but I don't think you will, because this is pretty interesting stuff, or at least he makes it entertaining. I just gotta
That
get
is
that.
so interesting.
I can't really offer much. Sooner or later, every programmer has to deal with time zones, and I can't really offer much advice here. I can offer a cautionary tale. I can tell you why you really should never, ever deal with time zones if you can help it.
He's not.
Let's imagine that someone has built an application that lets you calculate how many seconds something is in the past. You type in a date at a time, it gives you the number of seconds. And they look at that and think, okay, that kind of works for me. But let's add a little box that lets you change the time zone. So if you're comparing between now in New York and 5 days ago in London, you can work that out. And that's fine. The little drop down lets you change which hour forward or backward of Greenwich you are. Brilliant. Sooner or later, after it gets a bit popular, they'll get a call from Australia. And Australia will say, "G'day, mate." I'm not trying to do accents. I just shouldn't do accents. Australia will say, "Hello. By the way, we're 9.5 hours ahead of Greenwich." And the program will go, "Really?" I say, yeah, 9.5 hours. So, "Oh, okay, I'll add a special case for you, that's fine." Now, a little bit later, someone will call from Nepal, and they'll say, "Hello, we're 5.25 hours ahead of Greenwich." And they say, "Really?" I say, yeah, we've been there for ages. Yeah, 5.25 hours. Great, okay. And they'll put in a special case, and maybe they'll look up the list of time zones, the canonical list that tells you what everything is, and they'll make sure they've covered every time zone in the world. And then autumn will come along, and we'll get a call from England. And England will say, "Excuse me, we're an hour out at the minute, what's going on?" And they'll go, "Hold on, the clock's just changed." That's fine, no, we dealt with that. We made a note of when daylight saving changes for us, and we put that in. And England will say, "No, see, daylight saving changes a week earlier for us. It's different depending on where you live. We shift our clocks back a week before you do." And at that point, generally the program will start to hold their head in their hands and realise what they've got themselves into. And that's fine. They'll put that in and they will deal with each country shifting to daylight savings time on a different day. And they'll look at the file that tells them how to do that, and they'll copy all that in. Then they'll get a call from someone in the southern hemisphere again who will say, "Yeah, well, we're not shifting back in the autumn, we shift forward. Our spring is in November." And at that point, they'll generally start looking longingly at their intoxicant of choice, wondering if they should have a quick drink before keeping going, and then they'll code that in as well. And then they'll get a call from Samoa, out in the Pacific on the international date line. And Samoa will say, "Hello, yeah, we skipped a day the other year." And the program will say, "What?" "Yeah, we skipped a day. We went from December the 29th, 2011, to December the 31st. We shifted from one side of the international date line from being hours and hours behind Greenwich to being hours and hours ahead of Greenwich." It helps us with trading with Australia. Can you take account of that when you work out how many days things are and how many seconds things are in the past? It's fine. There's a file that tells you when any country has changed its time zone. It turns out that happens fairly often. But they're announced ahead of schedule, so as long as you keep that file updated and code that into your program's logic as well, it'll be fine. Then you look back and you notice that during World War II, England had double British summer time. It went completely onto BST and then just added an extra hour, so it was 2 hours ahead of Greenwich despite having Greenwich. Let's finally deal with that. Changing ever since started talking as if it was you or me, because I've done this before and it's really, really frustrating. You make sure that you subscribe to the list of when countries are going to change their time zones, which happens, apparently, many times. Like, sometimes several times in a year, because governments change over. And then the program, this mythical program, gets a call from Libya, who in 2013, with only a couple of days' notice, decided that they weren't going to put the clocks back. With enough notice that it wasn't possible for anyone to get the update out in time, and meaning that every Libyan computer, no matter what operating system it ran, was an hour out. It's okay, you read the news article about that and you hurriedly code that in as well. And then you get a call from the West Bank, where the Israeli population is on a different time zone to the Palestinian population, because one is following Israel and one isn't. And now you have two populations of people in the same location who are following different time zones. And now they're all having to ask themselves whether they're on this time zone or this one, depending on who they are and where they are. And there's no way to code that into your program. And then you get a call from the historian who says, "Right, I'm trying to calculate some times back in the 18th century, and we changed from the Julian calendar to the Gregorian calendar. And it's not that we lost about 3 weeks, it's just that we skipped right from this date to this date and missed the others. And can you code it so that it just kind of works that out for me? It's fine, because someone else has already told you when those dates are, and you can code that into your program's logic as well. But now it's looking really long and really complicated, this tangled mess of spaghetti code that somehow works out. And then you get a call from the Russian historian who says, yeah, we only changed the Gregorian calendar in the 20th century. And it turns out that the dates that you skip change depending on your location. And can you deal with that as well? And then you get a call from the British historian who says that until, I think it was the 16th century, the year started on the 25th of March. Just to blow your mind, on the 24th of March, 924, and then it will be the 25th of March, 925, and that is the next day, because you have gone from December 31st, 924 to January the 1st, 924, because it goes in that order and it's massively complicated. And then you get the call from the astrophysicist who says, by the way, we just had a leap second. And at this point, you just kind of go, what? Leap seconds. Because the Earth does not rotate at a constant speed. It slows down, it speeds up as tectonic plates move about and magnetic fields shift or something like that. And so occasionally, the International Astronomical Union will work out whether we need a leap second. And if you do, the clocks go 23, 59, 58, and then it's 23, 59, 59, and then instead of going like any sensible time zone would, it goes 23, 59, 60, and everything breaks because suddenly you have 61 seconds in a minute. So depending on your implementation, either your clock gets 1 second out of sync with the rest of the world, or it repeats a second. The way you're meant to deal with this is something called the unix timestamp. A number file, I think, has talked about this before, that you have this number that started at the first exact second of 1970 and increments 1 second per second, constantly, tick, tick, tick. And that's great, because what you're meant to do is you take whatever date has been given you, and you calculate that as a unix timestamp, and you put that into your database. And that'll just deal with leap seconds, except it doesn't. Of course it doesn't. Because you have universal coordinated time, which includes leap seconds, in that it repeats occasionally, and it just includes 23, 59, 60. And then you have astronomical time, which does not include leap seconds, and has steadily been getting out of sync with the rest of the world, because we need to look at the stars and design telescopes around it. And what you learn after dealing with time zones is that what you do is you put away your code. You don't try and write anything to deal with this. You look at the people who have been there before you. You look at the first people, the people who have dealt with this before, the people who have built the spaghetti code, and you go to them and you thank them very much for making it open source. You give them credit. You take what they have made and you put it in your program, and you never ever look at it again, because that way lies madness.
Well, you just quit answering your damn phone. Quit answering your phone. Why would you take a call from...
I don't know. Okay, so did you guys like that video?
Yes.
Tom Scott, computer file, number file. He's on a few of the number files. It's good stuff. Definitely look up Tom Scott. He has his own channel as well that I can't remember the name of, but he's good stuff. So, who thinks they understand time?
I think the problem is the human's way of observing when it's close to that. We just
We're
did
getting
seconds
really deep.
and use metrics, so like a kilosecond is roughly more than 15 minutes.
Oh, Swatch Internet Beats, you mean?
Pardon?
Swatch Internet Beats.
I'm not familiar.
Oh, Swatch back in the 2000s or so decided that they need to create their own time, and they created Swatch Internet Beats.
I'll look that up.
Yes, you absolutely should. In fact, you can even still buy a watch that keeps time in Swatch internet beats. No time zones, it's just if you're in different places than the beats that you start on and end on, or it's basically the same as metric. Which brings up a whole other story that I probably won't cover today because most people will be bored by it. If you ever get bored and want to look up a good story, find out why the clock goes from 1 to 12 instead of 1 to 10. All of our other systems are base 10, right? Particularly in metric, but pretty much across the board because we've got 10 fingers. So why does the clock go from 1 to 12? Another story, another time. What we can focus on, a small piece of this, right, is the stuff that affects us. I'll quickly address the programming part because that's pretty easy and he already did it. We'll do a couple of things as far as like sysadmins are concerned, and then we'll see how tired you guys are or how thirsty you guys are. We'll take it from there. Programming side of it. As he mentioned, you don't write your own, ever. If you guys have any pet projects you're working on, Python, Pendulum, excellent library for time stuff. There are other, in .NET, you want to use Noda-Time, N-O-D-A, Noda-Time. There are very good libraries for this, and you should never, ever, it's like writing crypto. Do we write our own crypto?
No.
Great answer. And we don't write our own time either, for all the reasons he detailed. It gets even worse, actually. The way that Windows keeps track of some of that information is wrong. And it's known to be wrong, but it's relied upon, and so they can't back those changes out. So like some of the time zones and stuff, dead wrong. Can't change it. So never write your own. That's my advice. You guys start playing with any projects, if you need something dealing with time, either use the ones that might be built in or go find a library. Don't do it yourself. So that's my little 2 cents for programming.
But with that code, also Microsoft will break from ISO.
Yes. Oh yeah. No, there's all kinds of wrong with Microsoft. But backwards compatibility, so we got to keep it. Right?
A fun little issue also is it's time drift, virtualization. If you don't have time synchronization from the hypervisor down, the machine just starts drifting off, and if that was misconfigured and was a domain controller, then everything starts drifting off. And
Oh yeah, absolutely. I heard somebody say Kerberos over here. Yeah, that's one of the effects of it. Yes,
yeah,
it
it sucks.
absolutely horrible. It's one of those things that makes you kind of want to set up your own time network. Hey, setting up your own time network. Let's talk a little bit about that. Sysadmin side.
Nice segue.
Hey, I try. Let me see if I can find it in here. If I can, then I'll just do it from memory, and you guys will have to put up with my not. Here we go. Not knowing exactly what we're talking about. So, network time protocol. If you don't know about network time protocol, it is what it says on the tin. This is a time protocol for the network. It can help with things like virtual machines getting out of sync. It can help with things like if you have VoIP phones, the clock on the phone getting out of sync, or computers on your network, keeping all of their clocks in sync. And there are a lot of very good reasons for this, but it can be as simple as trying to aggregate log data. What happens when you have multiple sources logging and the timestamp is off by a few seconds? Well, you make some wrong assumptions about what happened in those few seconds. That's long and short of it. So, how can we use network time protocol? The easiest thing you can do is just to pick one of the, I guess you could call them global servers that are out there for free, operated by NIST, or there's time.windows.com, I think. Is it listed? Yeah, time.windows.com, pool.ntp.org. There's a ton of them, and that's the cheap and easy way to get started. If you have a router for like a home lab or something, it's very likely you'll be able to configure that in the router and have it tell everyone else that gets a DHCP address from it, hey, this is who we talk to for time. If you have a little bit more intense needs or want to get in depth, that's where some of these things down here called stratums come into play. Stratums are just basically how accurate or how much precision of accuracy, yes, there are different things, can a given thing provide. And so the lowest one here, stratum 0, refers to an independent timing source such as a high-fidelity GPS receiver and atomic clock, like those operated by NIST. Someone said cesium atoms? Yeah, that basically will provide stratum 0. But you're probably not going to come up with your own cesium atoms and figure out how to actually clock them. If you do, I don't know why you're listening to me. You'd be making so much money right now. So we'll go down to the next option, GPS, right? How expensive is a GPS receiver for a computer
Less
these
than
days?
$2,000, you can get a really nice Stratum 6 GPS block.
Less than $2,000?
Yeah.
I mean, I just buy them for $30 on eBay, but yeah, that sounds good too.
That's pretty awesome.
It's all about the precision and well, the accurate precision that it can provide, right? And so you pointed out, Stratum 6 GPS receiver. GPS inherently carries a time sync. And actually some watches, wristwatches, will sync to that, wall clocks, that kind of stuff. But yeah, you can buy one fairly cheap. Depending on what your needs are, it can be one of the $30 ones. They'll even, some of them will connect via Bluetooth. You can get more complex ones. You can get ones with external antennas. Lots of very good options to get, if not a primary time source, a secondary time source. And it's a really easy way to do it. If you don't have an external antenna, obviously the computer's got to be near a window or something, but it's cheap and easy and isn't as painful as it used to be. You don't have to get the time source from...
The radio.
Yeah, well, radio, good point. Yeah, essentially, the time is now.
3, 2, 1.
Yep. Another one, if I remember correctly, was teletype. I believe teletype carried a time signature as well, but that was before my time. So yeah, we have this wonderful thing with these satellites in the sky. They fly around, they give us time. Awesome way to get into it. Stratum 1 machine refers to a machine that is directly connected to an independent timing source. The top level NTP servers have Stratum 1. You should not set up one of your servers with Stratum 1. If you do, you deserve all the hell that's coming your way. This is being recorded, isn't it? Yeah, well, what are you going to do? Stratum 2 is usually found on NTP host servers that service a large number of machines, such as time.windows.com. We talked about that. And those are the ones you're probably going to have for public consumption that you'll be consuming. You really actually don't ever want to set up a public NTP server. Another topic, if you guys get bored, go looking for exploits on those. There are many, they are varied, they are unpatched to this day. So don't do that. But internally, if you have it behind the firewall, if you have it properly protected, great idea to just set up a Raspberry Pi or something and tinker with it. Stratum 304 is often found on domain controllers in a network. They can be used as time sources. However, as you pointed out, if they're in a virtual machine, that can be a very bad idea, and you want to have an independent one. This is why I bring up the idea of a Raspberry Pi. Actually, any of the little tiny hobby computers these days, any of them that can run Linux will work as a time server just fine. You buy that $30 GPS dongle, suddenly you've got your own time server to play with, and a great source to keep those virtual machines in sync, particularly for something like a home lab. I don't recommend this for production, but hey, it can be useful. I'll also mention, just because that story made me think of it, if you deal with VoIP phones and you're constantly having issues, make sure you have a really, really, really good time source. Because if you don't, that can be causing the issues. The real-time encoding that they use depends heavily on time sequences. And so if you don't have that available, you need that to be part of your VoIP setup. So yeah, that's the basic idea of the Stratums, and that's NTP. Anybody have anything to add? Any comments or thoughts about NTP?
What's the biggest time source, or at least what's the most impactful thing on time that deals with anything with computers?
Is this a trick question, or are you just asking me for fun?
Kind of a trick question, but it's
Kind of a trick question.
power.
Of course the guy with the power grid.
No, seriously. You have to have a very, very, very precise GPS. Or why?
Not a clue.
Because of the hertz.
Oh, that makes sense. If anybody doesn't know what hertz is, hey, another research topic. This is not all inclusive. This is a fireside chat. Kamikaze like that. Okay. One more topic, and then we'll see if you guys are bored or not. Also, that webpage that I had up that I'll bring up here again in a moment is an excellent reference for all this kind of stuff. It's Internet of Things Journey, and it's all about time. And it's just a very, very good resource. The next thing that I'll bring up, and actually this doesn't matter, so I can just shut this. Next thing I'll bring up is logs, right? We were talking about logs and timestamps and all that kind of insanity. What timestamps should you log?
Time when it was sent and received at the server.
Time it was sent and received at the server.
Well, it's time it
So
was
the
sent
server.
by the source and received
Oh.
by the destination.
Okay, so time that it happened on the client
Yes, sir.
and the time the server received it. Even
Couldn't have said
though
it better, yes.
those might not line up.
But at least if you have both, you have a fighting chance, right?
Absolutely, absolutely. Actually, if you ask me my 2 cents, just generally, timestamps and logs like in syslog, UTC, or GMT, if you're one of those people. That, honestly, that has created the least amount of pain for me, because you don't have to convert them. It's converted at the time of inception. You don't have to worry about, okay, what date is this? How did daylight savings time work on that day? All of that kind of falls away, because in the context of a log, you really only care about the sequence, right? If you take it out of that context and want to extrapolate upon it, you might care about what time of day it was. Like, was this closing time? Was this actually 5 o'clock? That sort of thing. But when you're just looking over the data raw, most times you're wanting to know, okay, how long did these 2 things have between them, right? And so that's my 2 cents is keep it GMT or UTC. Don't try and include any of the fancy stuff. If you do want to include something fancy, then ISO 8601, I believe, I had it up on there, but it doesn't matter, includes the time offset. Not the time zone, important distinction, the time offset, so the offset of when it happened. Anybody else have anything to add about that? Any wisdom as far as logging and timestamps?
I have a question.
Sure.
When you get those horror stories and you have, let's say an incident, right? You do an incident response and you have an incident and all the different sources have different time.
Mm-hmm.
Hopefully you've got a SIM that correlates it and takes care of it for you. But if you're stuck at the syslog level, do you have any tips like, would you dump it all into one file and then have an extra column added to do the offsets for you? Or how do you kind of analyze that?
Well, to review what you said, the best idea is something like a SIM. An important function in the SIM in that case is just log aggregation. And you can do that on the cheap. You can write some Python scripts or PowerShell scripts if you're on a Windows box, right? That doesn't have to be that complicated. But once you have the logs aggregated, you have a lot more power available to you. An Elk stack, Elasticsearch Logstash in Kibana, or it's fine. It's fine.
Graylog.
Graylog is another good one. Any of those log aggregators, if you have a serious corporate network, put one of those on there and just go after it. And if that means that you're turning over logs and rotating them out daily, so be it. There's still so much power to be gotten from that, and it's something that you can't easily deploy into the past, right? You can gather whatever logs are available on the servers at a certain point, but it's better to have it and not need it than not have it and need it. As far as dealing without that, this gets tricky, right? Because the poor man's way would just be to aggregate it into one file. I would highly recommend against that. Because if you do that, most likely what you're going to be doing is taking like the host name and prefixing that to the line and dumping it all into one file. And what you end up with are files that are unmanageably large, right? And so like grep will take minutes or hours or days to get through one file. So that's a bad idea in my opinion. Quick and dirty, sometimes you have to do it that way. The better idea is to try and find something that looks like a log aggregation solution, either with Graylog or Elasticsearch or any of those. Or, worst comes to worst, like I said, build your own. Just sling a little Python, whatever you need to do. Maybe worst comes to worst, you create something that's just a cron job, that's one Python script running on one box, and you rsync or SCP or copy to an SMB share on that box, and then let it aggregate them into something. whether that's a flat file database, whether that's, MariaDB or MySQL, Postgres would be awesome for that kind of stuff, or something more complex like Elasticsearch. Any of those options, get it in some kind of structure. You'll be able to then query it a lot easier with structured query language. Yeah, I'm a dev, what do you want? So that's my 2 cents on that, is you really, in order to get benefit from it, you need it in some kind of structured data store. Having it just all in one file, you're going to have lots of pain. Not to mention you deal with the timestamp issues as well. And like you pointed out, if you have that aggregation in place, then a lot of times what you can do is have the server timestamp and the client timestamp together in that store, which allows you to leverage even more data, because now you can understand more complex situations that have arisen and a more complex sequence of events, rather than just but the timestamp says, and that goes hand in hand with the setting up a good time source.
Yeah, that's a good point. We were into a problem where the time source was inaccurate because maybe it was so overloaded or being DDoS that it couldn't timestamp properly, or the clock was jacked up.
Absolutely. A time server being DDoSed? Tell me more.
Amplification, right?
Happens all the time. Did I mention exploits still unpatched? Yeah, they really are there. Do you guys have any final questions? I don't think I'm going to make this much longer unless you guys wanted to go longer. Sure. Huh? I thought I heard somebody over here.
We're just talking about beer.
Yeah, it makes sense.
Beer
That's what
club.
comes next, right?
Beer club.
Right?
Beer and wine.
Awesome. Okay, well, thanks for your guys' time.